Okay, let's get started. Okay, guys, hello. We're getting started now. Daniel. Okay, great. Okay, Harry hitting back. Okay, good. All right. Hello, Melody. Okay, so I want to walk through what we're... Oh, we got accompanying music. How nice. Okay. So we're continuing on arrays today. So last week we tried a few milestones. We take up the milestone M3 and M4, and we started work on theory of arrays as data structures. So today I want to take up M5 flow, show how I would do the milestone, okay, and then we'll review theory, arrays as a data structure, we'll look at arrays and swap, we'll try to continue a little bit more theory, and then we'll do the application of gravity. You'll have an opportunity to try optics problem, then we'll take up the optics, hopefully, and then we'll have a chance to do M3, M4, M5 try 2, or M6 try 1, depending where you are on your progressing to date. Okay, so that basically tells you what we're going to do today. So let's start with our take-up guy, okay? I'll close this and we'll get to Blackboard. Okay. Okay, first of all, oops, wrong one. I want this guy. Okay, and I am recording correctly, yes. Okay, let's close this thing down. I want to do a UML. Okay, so what's the question first of all? Let's write down the question. So this is milestone 5 on flow. And the task is to print either the factorial, square, or cube of the integer of a positive integer entered by the user. Your program should give the user the choice of which to return. After prompting the name for a user for an integer and the required output, the main function could call functions named square, cube, or factorial to do the calculation. Call fprintf from the main program to print the final result. Okay, so I guess we obviously want to start with the, not a cluster diagram, sorry, a UML diagram. Okay, there's our start of our program. And what's the first thing we want to do is, it says we should prompt the user to input an integer. So input, let's call it k. Okay, first thing we're doing, input k. So I'll get my thing here, input k. And your program should give the user the choice of whether it wants to do a factorial, square, or a cube. Okay, so I'm going to have another input. I'll have to input, I'll call it choice. Input the choice. Okay, these guys. Input choice. Okay, based on the choice, I'm going to either do a square, a cube, or factorial. So that's a decision, right? So based on choice, I need to make a decision. Okay, let's say if choice equals, okay, let's go on and do choice equals, all right, let's say choice equals, where's my thing? Okay, if choice equals 1, if the person chooses 1, okay, choice equals 1, choice equals 1, I'll take this route. Okay, and where's my, oops, my arrow go longer. Whoosh. Okay, that's better. So if my choice equals 1, I'm going to go here. And what am I going to do with choice equals 1? I'm going to give the square. Okay, square. Okay. Okay, I'm just going to put, okay, so the output, I'll call it, maybe I'll call out equals k times k. Okay? Next, If that's not true, I'm going to go to, I'll have to have another decision. In this case, let's copy, I'll copy everything, simple. Okay, let's say choice equals 2, and I'm going to do a cube then. I'll do a cube, okay? Out equals k cubed. And otherwise, if it's not 1, 2, I'm going to assume it wants to do a factorial. So out equals k factorial. All right, so my UML now needs to come back together again. Okay, so let's just start to put them all together. This guy and this guy first. Then I've got to put the other two together too. So that means I'm going to need another one of these. So each diamond has its partner. And we end up with our end of our UML. We'll go down to here. And I need to print it. What does it ask me to print? It prints the print from the main, just the final result. I don't have to print anything but the final result. So I just have to print f out, my little variable out, and then I'm finished. Okay. All right, so that would basically be my program. I'm going to input k, input the choice. Person chooses 1, I'm going to do the square. A cubed if he does 2. I'm going to do the factorial if he tries something else. I'll combine together and then print the output. So I have my UML. So I'll move that over to here. So I have reference. And I'll start my coding. Okay, come on. Okay, there we go. Okay. File, save as. I'll put it into my C, SDBA. I'll call it milestone 5.c. Okay, so let's make it bigger for you guys. Okay, include. Okay. I'm going to use for my input, I'm just going to use, I think I'll use John input library simple. jinlib.h. I'll include it to get float prompt. I am going to need, I'm going to write my own function to square, cube, and fact. So long square, long k, okay. Long cube, long k, and long fact, long k. All right, so I have my 3 prototypes. I want a function to do out. I want to do squared, cube, and factorial. All right, and I need the prototype for the fprintf to do my output. So there's my, so I have prototypes for 1, 2, 3, 4, 5 functions. So now I'll start my main program. Okay, let's follow my thing, input k. Okay, long k, oh, I have 2 of them out. So I've declared 2 things, k and out. So k equals get float prompt. And if I forget how to write it, I can just file open jinlib.h, and there I have my, there's the way it should be done. Get float, I don't want get float prompt, I want get fixed prompt, right? Because it's long integer, not double. So I've got the wrong one. So I can just look here and say, oh, it's this guy I want. I'll get rid of him. correct my mistake. Print put, and I need my prompt here. Positive int. Okay, input a positive integer. Okay, good. And the other one I need to get is the choice. Oh, I need another integer. Choice. I forgot him, because I'm going to input choice, so I got to get choice. Equals, get fixed prompt. So I'll just put choice, okay, maybe 1, 2, 3 for square. Now let's do this 1 for factorial. I think it's more sense. 2 for square. And maybe I'll put a 3 for factorial. Okay, so forget that. I'm going to change this to a 2 in my UML. This to a 3. Okay, otherwise I'll do a factorial. Okay, and now continue on my main code. My main code now, okay, sorry, I'm going to shrink it a bit, sorry. And this side should shrink down too, I guess, because it's getting too big. Okay, so I got my get choice. Now, next on my UML says I need a if. If choice equals 2, I'm going to call out equals square of k. Okay, if it's not, else if choice. Okay, so if the first thing is not true, it'll try the next case. 3 out equals cube. Okay. And if it's nothing of those, if it's not 2, it's not 3, then I'll just do out equals fact k. Okay, so we see the flow here. It'll first check. If I chose 2, it will it'll call square. It will then check. If I didn't choose 2, else, I did not choose 2, I'll check. Is choice equal to 3? If it's equal to 3, I'll do this guy. Okay, otherwise, I'll do out equals the factorial of k. And then f print f, standard out, %ld, out. And I'm fin and return 0, and my function, my main function is finished. So I've got my prototypes. Okay, I've got calls. I'm calling get fixed, calling, calling, call. So I now need some definitions. Okay, let's copy all these 3 prototypes down and write our definitions. For the square, open brackets, close brackets. I can do a few different ways. I could long temp equals k times k, return temp. Okay, there's square. Cube. Okay, long temp equals k times k, return temp. Okay, those 2 are relatively straightforward. Now factorial is a little bit more challenging, right? Because we know what factorial is. It's like 3 times 2 times 1. So it's going to have to be a loop. So long temp. Okay. So maybe I'm going to put my temp. Okay, long temp. Let's start as 1 equals 1. All right. So for, I'm probably going to need another guy. I'm going to have to, if I'm doing a loop, I'm going to need a k. Another thing. Long j for my loop. Remember, we got to count all the way up. So for j equals 0, Now we don't want to start at 0, we want to start at 1. J equals 1. J less than or equal to K. We want to do the maximum one is multiplied by K. And then we want to just J plus plus. Okay. Temp times equals J. Okay, right? So it's going to do, first time it goes through, it's going to do temp times 1 is 1. Temp then it's going to add 1 to J. Temp times 2 is 2. Temp equals 2. 2 times 3 is 6. 6 times 4 is 24. Okay, it looks like it's going to work. Return temp. I'm not going to worry about it too much. If I've got something wrong, I'll just check later. Okay, so I just want to make sure my program will run now because I think I've got everything written that I need. I've got my prototypes. I've got my calls. I've got my definitions. It looks like I've got everything I need. So I'm going to go now to ANSI C, go down to my, find the, here's mine. Okay, and get to C, local disk, SVBA, ANSI C, more info, run anyway. Okay, here we are. I think I'll close U, okay. GCC minus C minus wall. I want the warnings, M5.C. Oh, no problem, great. So surprise. Okay, M5.exe, and I got it M5.o, and I've also got jinlive.o because I got jinlive.h there, so I have to include jinlive.o for get fixed prompt. Okay, great. M5. So okay, positive integer. We want to test, so we want an integer that we can calculate very easily. Let's try 3. 3 is a nice easy number to calculate. 3. And let's do the square first. So square should be 9. 9. Okay. Let's try again. M5. 3 again. Let's do 3. 27. Uh-oh. 3, that's not factorial, right? That is a cube. Oops. So I'll change that. 3 is a cube, not a factorial. Okay. All right, so that's a minor. Okay, I can correct that. Let's try again. Compile, link, and we'll run one more time. 3 cubed, yes, 27. And finally, I'll try my factorial, M5, okay, positive integer, 3, do a factorial, it should be 6, right? 3 times 2 times 1 should be 6, it's 6, okay? And just one more test you should probably do is to say, what if I put something else that's totally different, like 99? Does it do any 96? Okay, it doesn't crash. It just gives it defaults to doing the factorial, right? Because I'd say if you print anything else, it will do factorial. Okay, so but I'm not worried about that. If I wanted to, I could then add a thing saying, please input 1, 2, or 3, but that's all that would be required for it to actually work. We can also do another test. If I want to M5, what if somebody puts in -4? Factorial. Okay, it's safe. It didn't crash. Okay, so depending how you wrote this for loop, if you wrote it with a while loop, it's quite possible this would cause it to crash and go -4, -5, -6, -7, -8, -9, and would go on forever. Okay, so this is safe. It's not, and anything else I would like to check, probably another -4, 5 for a square. Okay, 25, okay. M5, we'll try -5 for a cube. Okay, cube is also okay. So square and cube are okay with negative numbers, so only factorial is the one that is not going to have some problem with negative numbers, but it's not going to totally crash. Okay. That brings us to the end of, so that's our taking up of our milestone. So let's look what is our next step. Don't save, okay. Okay, let's continue on. Okay, so we're going to continue on with theory now. Arrays is a data structure. And as usual, our mic is dead. Yep. I think it's always... Just a sec. Okay. Okay, thank you. Let's see if one of these work. Okay, it's got power. Okay, good. Okay, now we can have some, make it easier. All right. Okay, so we're going to be working at arrays as a data structure. So we're moving again back to the textbook, SDBA textbook, and I'll grab that from my, all right, from, okay, not that one. Okay, this one. Okay. Okay, we've been looking at arrays. I talked about before, if you remember. Arrays and records are both built into C. Of the 8 basic data structures, only arrays and records are built in. The other ones you have to make yourself. So an array is a grouping of the same type of data: variables, fixed point, floating point, or pointers. So we talked about why we want to use arrays. We talked about how to declare an array. We talked that memory is allocated sequentially. Okay, there's a VP diagram of an array, what it looks like. Each element is represented by a variable. Variables are stacked on each other, contiguous memory locations, and none of the variables have a name. None of these variables have a name. They have a handle, and there's a pointer directed to the first element. That's the only thing with a handle, is this one pointer. Okay? And so the only way to access a variable is via the pointer. And that's whether you're in Python, in C, JavaScript. It doesn't really matter what language you're in. It's the same way. You just may not see it. Okay? So the access is pointer plus offset. Therefore, the first element of an array is always 0, not 1. Okay? We can also make them pointers. So when we're working with arrays, we have to declare, initialize, use, but between declaration and initialization, we have to allocate memory. Okay, this is an additional step when we're working with arrays. And we can do it in 2 ways, static or dynamically. And in static memory allocation, memory is allocated at the same time as the array is declared. So in this case, when you write the program, you need to know how much memory you're going to need. Okay? In dynamic memory allocation, memory is allocated at runtime. So in this case, when you program, you don't need to know how much memory the person is going to need. It will be assigned when the program's running. So each of them has advantages. Static will be faster. Dynamic will be slower. Dynamic will be flexible. Static will be very fixed. Okay. We showed here how we declare an array, how we fill elements in an array. Okay, n equals 3, there's 0, 1, 2 are all the elements. And we looked at a number of questions. Here's the declaration statement for a 1D array. We have the type. Could it be int, long, float, double, char? The handle for the array, in other words, the name of the pointer. The pointer is called C. And how much memory have we reserved? 3 places. So in other words, we reserve C0, C1, C2, C plus 0, C plus 1, C plus 2, but we have not reserved C plus 3. Okay? It only goes from 1 to 2. And these guys make how many dimensions you have. 1 hard bracket per dimension, maximum 12. Okay, So here we are at the 1D array, 2D array, 3D array, 4D array. Okay, we don't usually use many multi-dimensional arrays, and in this class we will never use them. But if you're doing matrix multiplication, for example, you probably would, right? If you're trying to multiply matrices, etc. Okay, first index of array, okay, is 0. Why? Because a pointer is a plus offset. Okay, we talked about how it's done, why we do it this way. We talked a little about constant macros. This is a macro, define n3, right at the very beginning of the program to define the array size. Why don't we use a number? Because it makes debugging easier. We can see if I type 525 rather than 523, it's difficult to find this mistake. But if you type M rather than N, the computer will give you an error. It also makes modification easier. If I write a program to handle 400 students where the class becomes 450 students, I can just change one thing at the very beginning and I can now handle 450 students. So printing arrays is element by element. In other languages, you can print the whole array at once. We can in C. We have to do a for loop. For j equals 0, j less than n, j plus plus, print j, cj, and that would print the whole array. Okay, and we didn't talk yet, but now let's talk about the other way of allocating memory. So the first way is static allocation. Now we'll do dynamic allocation, okay? Let's look for a second at this code. I'll give you about 2 minutes to look through it, and then we'll go through with VP diagrams. Okay, as we walk through it, you can see we have stdlib at the very beginning. This is a different library you haven't seen yet. This library contains the function malloc. Okay, so we need to have this library function. This one was standard input and output. This is the standard library for C, so we want malloc. Okay, all right? Okay, first of all, we declare a fixed point variable and give it the name handle j. We declare a pointer, give it the handle Jane, and this is the main line that does the magic. Okay, so we call this function malloc. So malloc, we give it some things. We want to allocate memory, request from the operating system, room for 3 variables. The size of each variable will be an integer size. So a size of calls the operating system, it makes a request to Windows. Windows, how much room are you allocating integers to right now? So if it's a 32-bit system, it will return 32 bits. If it's a 16-bit system, it will return 16. If you're running 64-bit Windows, it will return 64. If you're running a 128-bit operating system, it will return 128. Okay, so this will return how much space each integer is used right now, and then it says, give me 3 of these, so 3 times this much space, and then malloc. So first of all, we call the operating system, we get the size it's using for integers, we multiply by 3, we want 3 of those, then we call the operating system again and say, okay, give me this much memory, and then the operating system returns, okay, here is a point, here is the address of the first piece of memory that I'm giving you, Windows tells us. And then I store that memory location in the container Jane. Okay, so that's basically all this is happening to allocate these 3 pieces of memory. Now, I can start, now this looks exactly like an array, right? And it is an array. It's just that I've broken up I've now done it dynamically rather than statically. And now you can see I can just basically start to put stuff into it. 1, 2, and 1 and 2. Okay, we just input these guys in, output them. Nothing exciting here. Okay. So allocation follows declaration. Okay, so please note that. So you allocate first, then you declare, then you allocate. Okay. Okay, there's a whole bunch of dynamic memory allocation, but probably this is more like a secondary. This is ISO style. You may see when you read computer programs for doing dynamic memory allocation and use size of star Jane. But that's a different way of doing it. One is ANSI style, one is ISO style. So initializing arrays, that's where we got to last week. Let's now talk a little bit about it. Okay, there are many ways of initializing arrays. You can do it in the declaration or after the declaration. But C is unlike Python. It's not like Java. Python and Java both initialize everything to 0. It cleans the memory for you. C does not. The reason it doesn't is because it wants to be fast. It doesn't want to waste time doing that. Okay? The goal is speed in C. Okay? So we're going to show you a whole bunch of different ways of initializing here. So as you look at this, you're going to ask yourself, how can one initialize an array? What is automatic allocation? What do elements that have been declared but not initialized contain? Okay. Okay, this will take a little bit of time for you to look through, but this gives you a whole bunch of different ways of initializing different ways and different things. The initialization is all at the very beginning, and this is just printing out what we did. So we got a bunch of ways of initializing up here you can look at. Okay, we can now do a walk through the code using VP diagrams. Okay, so this is basically what's going to, this is the key part of the source code that we want you to look at, was this little section. This is the initialization section. And this is the output that you get when you use this, when you run this code. This is what the output looks like. Okay, now let's walk through again.
宣告一个 main function 起始于此。
宣告 J 为整数。
宣告阵列 A 大小为 n， 其内容为随机初始值。
宣告阵列 D 大小为 n， 其值依序是1、2、0， 最后一个未定义，自动给0。宣告阵列 E 大小为 n， 内容全都是0。
Okay, you can see how if you initialize part of the array, the rest of the array is initialized as 0. If you don't initialize anything, you have random numbers there.
宣告阵列 F 大小为 n， 其内容为随机初始值。
Okay, and now we're going to do a type of car, which is a whole bunch of, which is just bytes, and oftentimes we use bytes to hold characters.
宣告字元阵列 Goat， 其值内容为 Zarina。
Okay, so and it automatically put enough spots to hold the whole array of Zarina.
利用 for 回圈，从 J.0 开始，到不小于3结束。J.0 将阵列 A 编号为0的值设为0。
Okay.
J.1 将阵列 A 编号为1的值设为0。J.2 将阵列 A 编号为2的值设为0。J.3 跳出 for 回圈，印出指标。利用 for 回圈，从 J.0 开始，到不 J.1 印出 J 的值1。J.2 印出 J 的值2。J.3 跳出 for 回圈，
印出阵列 A 等于。
利用 for 回圈，从 J.0 开始，到不小于3结束。J.0 印出阵列 A 编号为0的值，其 J.1 印出阵列 A 编号为1的值，其值为0。J.2 印出阵列 A 编号为2的值，其值为0。
Okay, so you can see how we're sort of moving through.
J.3 跳出 for 回圈，
印出阵列 D 等于。
利用 for 回圈，从 J.0 开始，到不小于3结束。 这一点引领印出阵列 D 编号为0的值，其值为1。这一点1印出阵列 D 编号为1的值，其值为2。这一点2印出阵列 D 编号为2的值，其值为0。这一点3跳出 for 回圈，
印出阵列1等于。
利用 for 回圈，从 J.0 开始到不小于3结束。J.0 印出阵列1编号为0的值，其值。J.0
Okay, we'll skip through that.
J.0
印出阵
J.3 跳出 for 回圈，
印出字元阵列 Goes 等于。
利用 for 回圈，从 J.0 开始到不小于6结束。J.0 印出字元阵列 Goes 编号为0的字元，其字元为 Z。J.1 印出字元阵列 Goes 编号为1的字元，其字元为 A。J.2 印出字元阵列 Goes 编号为2的字元，其字元为 R。J.3 印出字元阵列 Goes 编号为3的字元，其字元为 I。J.4 印出字元阵列 Goes 编号为4的字元，其字元为 N。J.5 印出字元阵列 Goes 编号为5的字元，其字元为 A。J.6 跳出 for 回圈。
Okay. All right, so hopefully that gives an idea on how that works. Okay, let's look at some questions. So we can see different ways of initializing an array, within a declaration or after a declaration. Okay, first of all, after declaration, we use a for loop. If you want to declare and initialize a complete array, you have to use a for loop to initialize all elements to a required value or to 0. So for example, for j equals 0, j less than n, j plus plus, aj equals 0 is how you would initialize the array A. Each element must be initialized individually after a declaration. Within a declaration, it's different. We use curly brackets to specify values to initialize the array. And then the compiler allocates memory, reads each value and places it in the next memory location, and then when no more values, puts the remaining elements of the array to 0. So for example, when I do this, D3, 1, 2, the first and second elements are set to 1, 2, 1 and 2, and the third element is set equal to 0. Automatic allocation is, if I don't want to state the number of elements in the declaration, I can give values within curly brackets, and the compiler will then calculate how many values there are, and then allocate sufficient memory, and place the values in the allocated memory. So, for example, Gauss, the compiler first counted 1, 2, 3, 4, 5, 6, declared an array of size 6, and then placed the values Z, A, R, I, and A into each element of the array. And declared, not initialized, contain random numbers. Okay, all right. If I do this statement, what's in C0, what's in C1, what's in C2, and what's in C3? Okay, we'll give you a second, then we'll take some random people to answer this question. Okay, please discuss with your partner, and then we'll get some random people to answer. Okay, that will be Sean Wong. Sean Wong. Where are you, Sean? Sean. No Sean? Okay, no Sean. Oh well. Let's try again. All right. Okay. Bill. Okay, Bill. C1, C0. What is in C0, Bill? C0 is, try again. Correct. 1 is in C0. Very good. All right. Yay. Good job, Bill. Excellent. Yay. Okay, good. All right. Bill, good. Okay, good. All right. Next. 28 is David. David? Yes. Okay, what's in C1? Good. All right, David. Yes, 0 is in C1. Very good. All right, good. Excellent. You seem to know what we're doing. Good. Either that or he's a lucky guess. One of the two. Okay. 28. David is good. All right. Next is 38. Whoa. Fazl's not here. 6. That should be Brian Wen. Brian Wen. Okay. What is in C2? 0. Good. Good, 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 Brian. Yay. All right. And finally, Kevin Chen. Kevin? Where are you, Kevin? Kevin, are you here? Oh, not here. Oh, you are here. Good. Okay. What's in C3? What's in C3? Beep, beep. No. Beep. Beep. Anything we don't know. Does not exist. It's not part of the array. The array is only C0, C1, C2. C3 is not part of the array. The array is 3 long. The 3 elements are C0, C1, C2. There's no C3. Okay? There is no. That's an. Okay. So, all right. Good. All right. So, all right. Okay. Come. Oh, wrong word. Okay. We don't know what's in C3. Okay. That memory location, not sure. Okay. Let's move on to usage. Okay. We're doing a following object. We're going to look at, we could use it to calculate function of time, but we are, these are the equations, remember, that we're wanting to work on, and we can think of writing them in an array. Okay? So this would be an example of a program written to do that without functions, but we'll skip over this now, and we're going to, okay, and I think we'll skip over this right now. And we'll move on to our break. Okay? So 10-minute break now. Okay? We have a 10-minute break up. Okay? Okay? All right? Okay, so we're going to look at arrays and functions, and then we'll start to apply to our following object. So right now you can open the teaching notes to section 6, arrays and functions, swap, page 20 in your book. So page 20 in the handout book, please. So you got your book, please go to page 20. Okay, page 20. That we handed you out, the book, page 20. That's what we'll be looking at right now, the code there. All right, so if you open your book to page 20, we're looking at a code called swap. As you can see in your book, the purpose of the function is to swap the contents of 2 arrays with each other. In other words, what was in array A will be in array B, and what's in array B will be in array A. And we give the function access to the array by passing a pointer to the first element. So note that passing an array to a function is the same as passing the address of the first element, i.e. the function subroutine has prepared a pointer to hold the address. And there's only one copy of the data. Okay, so let's look at that now. All right, we've done, okay, there's the code that I want to look at here. It's similar to the one in the book. I think I just changed the numbers a little bit on this guy. Yep. Okay, and we added a little print array at the very end. So the main program is basically the same, but I've added something to print what's inside the array. Okay? So let's look through this code. We're going to walk through with VP diagrams, and then we're going to see how it prints. Okay. So, again, we have our information for the human reader. It's talking about functions and arrays, originally written by Andy Chung, where a number of years back, a student in our C course. And also I may just check it, okay? I'm only using one. I'm only using stdio.h for function prototypes. That's for fprintf. Okay, here's my preprocessor. I'm defining m equals 3. So everywhere m occurs in my program, before the program compiles, m will be replaced by 3. So this m will be replaced by 3, 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 all the way through my program. Okay? And a few function prototypes. One is going to print the array, and one is going to do the exchange of the two arrays. Okay, function main starts, and it creates, it's got a pointer, and it's allocated 3 places of memory, right? M equals 3, so it declared 3 places of memory, and it put the values of 31 in the first one, 11 in the second memory location, and 0 in the third memory location. Okay, so we have 31, 11, and 0. I then declare another array. Okay, we declare the array. It's array M with M elements, so 1, 2, 3, and we put the pointer B to it. We store the first address into the pointer B, and we put in the numbers 24 and 26 and 0. Okay, I've now set up my main program. I am now going to call the function exchange. So function exchange is now being called. It is being called. Okay, function exchange is now called. What does exchange receive? It receives A and B. Now, A and B are, and it receives, this is the same thing as writing star M, star N. They're both pointers. So exchange has prepared 2 pointers, one M and one N. It receives the address of the first element of the array, and this receives the address of the first element of the array B. So that's stored into N. So both of them are now pointing at the same thing. There is only one 31, 11, 0. There is only one 24, 26, 0. So both of them are now pointing there. Okay? We declare 2 integers, I and temp, to hold things. Okay, these are just temporary holders. And now we start this little for loop to do exchange. Swapping is quite a common operation, and we'll look at how we do that. Okay, first of all, I equals 0. Okay, I is now 0. It's obviously it's checked. It's less than M, so I'm going to enter the loop. I copy the value from MI, M-0, 31 is copied into temp. I then am going to copy the value from NI into MI. So N0, the value that's stored in N0 is going to be put into M0. So 24 is now copied from here, from N0 to M0. And now I take take the value of temp and put it into N0. Okay, I've now swapped the first 2 elements of the array. Okay, I is increased by 1. We have the increment of I. We check, is I less than M? It is less than M. So we enter the loop. Okay, temp is equal to M1. M1, that's 11, is placed into temp. We take that number, value, we put it into temp. We then take the value from N1 and put it into M1. And then we put the value that was in and temp, we now put it back into N1. Okay, so N1 now has the temp in, so N plus 1. Okay, I is less than M, we enter the loop. Probably not necessary since they both have zeros, but anyway, so we take the value of M2, put it into temp, which is 0. We take the value of 0 from temp and put it back into Ni, put it into 0, 0, and you don't really see anything happening because it's all 0. Okay, now I is equal to M. I is now 3. 3 is equal to M, so it's no longer true that I is less than M. So we exit the loop. And we jump back to the main program. So you can see that we've changed now. 31 and 11 are now in array B. 24 and 26 are now in array A. Okay, we've completely swapped the two arrays. And we'll move down to print them now. Okay, print array A. I'm not going to print B, I'm just going to print array A. Okay, so my print array, I again give the address. So it's receiving an address, a pointer, A. So it receives the address that was in this A and puts it into this, its own A. Okay. They're different A's, okay? This is print array.A, this is mains A. So there are different variables, different memory locations. They're not related. This A and this A have no relationship, okay? They're just pointing to the same place. Okay? Print array now gets a K. K is set equal to 0 when we enter the loop. 0 is less than M minus 1. M minus 1 is 2. 0 is less than 2. So we're going to enter the loop. What's the first thing it does? It adds 64. I'm adding 64 to the first element. So that's A0 plus equals 64. So A plus 0, this memory location, I'm adding 64 to it. Now I print. No, I'm printing in two different formats, %D, %C. %D says I'm printing the number 88. 88 can be used to store the character C. It could represent the character C. So if it's representing a character, it's representing the character X. Okay, so these two things are printed. %D, %C. We then enter the loop a second time. K is less than M minus 1. K is increased to 1. 1 is still less than 2. Okay, enter the loop. So it's going to take, we're now pointing here, 26. 26 plus 64 is going to be 90. We want to print it. We print %D is the integer, 90. And Z is what it represents. If we're using it to hold characters, it would represent Z. And finally, I check again. K equals M minus 1. In other words, K equals 2. M minus 1 is 2. We're going to exit the loop. I'll jump down to this F, print F, and it says print %S. %S says this array is going to hold a string of characters terminated by a 0. 88 represents X. 90 represents Z, and 0 means end of string. So it'll just print XZ. Okay? So you can now see how C is also storing Python, C, or any language, how they store English characters. They're all stored this way. Okay? And it just, the %S allows you to print the whole string. Okay? And that's the end of our swap function. And note, these are different ways in which these numbers can be represented. So 88, 90, 0 is what is stored in the array. If I print it as %C, X, %C, X, or if I did %S, it would just assume it would do the whole thing. X, Z, and unprintable character. End of array, not printable. Okay? So that's our swap, and there's our finished our swap, and we return, and that's over. Okay. We've now finished the theory part. Let's now move to application. Okay, you can look at your notes here. There's nothing here to say. You can see the code is in your notes. You can look at it yourself again there in your notes, or you can also look at it we'll upload the PowerPoints. We'll also upload it as well, so you can look at it on PowerPoint if you want, or in your notes. Okay, now let's move on to applying to gravity. So, you should be looking at now page 33 in your book. We're going to page 33, the gravity example. Okay, we're going to gravity now on page 33 in your book. This will be the first example we work on, then you'll be able to work on optics yourself, and then we'll take it up. But I want to guide you through gravity. Okay, anyways, okay, so we're working through that, but first of all, what do we want? This is our current program we've got for gravity. Right? Okay, this is what we've got so far. Close this. Close it. Get rid of this thing. Okay, we don't need this. Okay, that was our UML for our first looping program. Remember, we read one V1, read a V2. We then check. If T2 is less than 0, we're going to stop. Otherwise, we'll keep looping. We'll calculate T average, and we calculate the derivative. We then save okay, T and V, okay, actually this is V this time, the next time will be A, we say V and T, we then set V1 equal to V2, T2 we put into T1, we read a new V2 and T2, and we repeated the loop again. And this is basically how we were working. Now if you notice when you did that, we have input part of our program is here. We got some input coming in here. We also have, this is probably also so we got input here. We've got calculations stuck here. And we've got calculations stuck here. Okay. And we've got the output stuck in here. Okay, so in this sort of program, we have input, calculate, output, 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 input, calculate, output. This is the way we have to write the program if we're using files and variables and pointers. If we want to use an array, we could put all the input in one spot, all the calculations in one spot. Okay, I'm gonna, what's this guy? Okay, get rid of it. Okay, I want you, all the calculations in one spot, and then all the saving in one spot. Okay, so we're gonna redo that. We're gonna start to move things around and use arrays. Okay, let's switch to using arrays. Okay, I'm gonna have to, I'll move, so my input is gonna be the first thing that starts. Let's move him to here, read, okay, this will probably have to switch to, so let's maybe n data equals 0. Okay, I've got no data yet. Okay, and then I'll have a read. I'm just gonna have one read here. Let's move you out of the way. We're going to try to get all the reading in one spot. Okay, there, the data. Read him. Read V. Okay. Okay, read, say, H brackets 0 and the height 0 and the T brackets 0, the first T. Okay. T0. Okay, so it's still the same read. Once we read it, we need to check, is T less than 0, right? If T's Okay, if t is less than 0, we're going to be finished reading, right? So that's basically the question there, is t less than 0. So t, so this case is t 0, t 0 less than 0. I'm going to just take this out and not bother put the whole block. Is t 0 less than 0? If so, I'm basically finished. If not, I'm going to have to read again. Okay, so my reading is going to come back, and I'm just going to keep reading. Okay, there's going to be a few things I'm going to do. If it's not that way, I will. Okay, this is actually probably say end data, right? Because it's the first place, end data. To generalize it. Or why don't I just do k first, make it simpler for me. K, and I'll just put k equals 0. We've got no values in. We would then check if t is, we're finished. If not, then we're going to have to move this guy over a bit, move you over a bit. I want some more room there. So if this is, okay, come on. I want you to go to here, you to go to here. Okay, let's move you up. So we're up here, you're going to move over here a bit. Okay, good. Okay, so I'll add 1 to k. Right? I'll just add an additional k, put in this, and then I'll read the next piece of data, which means my arrow's got to come back into here. So I've got my loop. So I'm looping until I get a less than 0 time. Okay, so I've got all my inputs now in one spot. I'll move all this stuff over here so it's out of the way. All my inputs are now in one spot, so basically this is all my input is now just stuck in this section. Okay, all input is now finished. Range, order, bring to front. Okay, there it is. There's my inputs part. I'll make this arrow a little bit longer so it goes out of here. Okay. Okay, once I've finished my input, since I'm now using arrays, I can now start to go into my calculation part. Okay, so first of all, the first thing I need to get is how much data do I have? So k equals 0, I read 0, 0, 0. So I read one extra number. So end data equals k minus 1. Okay, so the number of data points I read was one more, right? The last point is is not a point, right? It's the minus 1, minus 1. So, and then I'll have to set k, okay? That's k equals 0. Okay, I don't want a subscript. K equals 0. Okay, there we are. End data equals k minus 1 and k equals 0. All right, so that's where we're going to go next. Let's see, how am I going to get into them easily? Let's go straight down and get k equals 0 right into here. Okay, and then I'll come out from him. Okay, now what do I do there? I've now got all this data. I'm going to have another loop, right? This is going to be now my delta h over delta t will probably be like the h k plus 1 minus h k over t k plus 1 minus t k. Okay, there's the tk's. And my average times are going to be the same thing, like the t, my new t for my new t for my next array. So I'll call this the vt, vt k. So the time for the velocity, I'm going to have an array for that too, is going to be like a t k plus 1 plus t k divided by 2. Okay, there's my v of t, and this is my v is here. I'll get rid of this delta h stuff. Okay, put my v there. Okay, so v should be here. There's my v of k. Okay, so it's going to be a little bit wider, unfortunately. Ooh, okay, he's wide. This guy got to fit into here too. So now I've got these two things happening in parallel. This can move out of the way. Okay, this save is going to go somewhere else. So I'm not going to save them anymore. All right, so that's the key calculations I have to do, and I've got to put this into a loop, right? So this is going to have to be a loop. So let's get another one of these loop guys. Right, we're going to keep going all the way. We're going to do all the k's, all the way from k. So in other words, it's going to end when basically the k, it's going to have to end when k is basically equal to n data, right? K equals n data is when it's going to end. Right, k equals n data, we're finished. We've done the whole loop. Otherwise, okay, otherwise we're going to keep looping around. So this guy is going to then come into here, and we're going to have to, okay, this guy, come on here. Okay, maybe I should move over this guy, move over, thank you. Okay, and then k equals n data is coming out. All right, and I'm looping this way, and finally this guy has got to be, I've got to do a k plus plus. Right, each time I go with my loop, I'm going to have to increase empty loop. Okay, there's my k plus plus. And this arrow is also going to go into the same, here we go to here, and I need one more. What's this guy thing doing? Okay. He will shoot from here and come into here. Okay, so you can see now, like, okay, so I've input an array h and t. I know how much data I've got. Now I loop it around and create a second array, v and vt. So I got v of k and vt of k. I loop around. Okay, once I've done that, I'm going to have to output everything, right? So I'm going to have to save v and t. So I'm going to save, it's going to be another loop, v of k, comma vt of k. I'm going to want to save that, and it's going to have to be in a loop too. So this loop will probably, so we'll come into here, and we're going to get another k equals 0, right? I'm going to need another k, need another k, oh, okay, I don't like you there, I want you, thank you, d, okay, thank you, okay, I'm going to reset k to be equal to 0 again, so I start my output. Let's move you way over here. So k equals 0. I'm going to save vk. It's going to loop again. I could put this triangle, okay, right here, I guess. I'll put my triangle right here. I'll run this guy straight to the triangle, okay. All right, and then it's going to be the loop, and I'm going to have a k plus plus in the loop. Okay, it's going to look something like this. I need my arrow again. First case, I'm going to save. Oops, save. This arrow is going to jump to here. And then we're going to go to here, add an extra k. And from k, we will then jump back up to here and keep looping around until what happens? K equals n data, right? Or k equals n data minus 1. So, and we're just going to base it, and that will be the end. We'll print it everything. So that would be another one. K equals n data minus 1. Okay, so I've basically done, I've now, okay, let's see. So this is going to be the calculation part. Is, okay, where's my, okay, output part? Output part is over here. Right? My output is all now together. My calculations are now all together. Okay? So I've got, and my output's all together. So I've now switched it from being slightly different format. Now it's an input, calculation, output. Okay? By using arrays, we can actually do this. All right, so let's now continue on, and we'll try to slowly walk our way through this. I gotta check our time. Yes, we are okay on time. Good. Okay. I don't need you anymore. Delete. Don't save. Okay. Okay. So there's our UMLs. Okay. This was our repetition code. You remember, we're getting the y and t, do while, we calculate the derivative, calculate the mean, we print t2, next update, and they get y2. That was the UML that we had for that. Code works, problem is solved. Minor limitations, we need to run the program twice. Input, calc, output are together, and we can't format as one table. Not major problems, minor things. One solution, but maybe not the best, is to use arrays. You can run the program once, separate input, output, and format as one table. Okay, so this is the way if we had to do it twice. The first time we calculate the V, and the second time we use the same program runner the second time to calculate the A, because it's the same calculation. Now as we move to arrays, as we just said, we basically start to do this as I equals 0, we read more data, we loop again and again and again, input. We calculate the velocity. Okay? We then calculate the acceleration. We would then finally we print everything. So we have one do while loop or while loop, for loop, for loop, for loop, and 3 for loops to output everything. Two for each calculation of for loop and for the output. All right. So we want to now modify the code that we have to actually do this. Oh. The battery's died again. Oh, wonderful. Okay. All right. So we're going to look at that now, and probably we'll switch to Google Meetings so you can actually, if you want to modify with me, or do you want to modify? Yeah, we can do that way with Google Meeting. Okay.
I've sent the link.
Okay. So when you're logged in, just download G7 Loop, which is this guy right here. Oh, yeah. So please download G7Loop.c so you can actually work on that. That's the one we'll be modifying. Later you'll be modifying 07 Loop. Okay, but right now we're going to be modeling G7 Loop. Okay, G7 Loop is the one we're going to modify. Okay, we'll be modifying the loop code to store y and t and b and c t as in arrays. Okay? Okay, so you want to download G7 Loop. Okay, that's this guy right here. Okay, so G7 Loop you should be downloading and getting onto your screen. And then we'll start. So all changes we're going to make will be in the main function. We're not going to be changing anything in the subroutines. Okay, so we don't change anything in subroutines. Okay? All right, I think most people are sort of okay.
This side is okay.
All right, are your side okay, guys? You guys got two people over there, right? Alec and Jabe are both okay. Everybody's okay? All right, okay. Let's start looking at the slow modification then, okay? As soon as I get this guy, okay, full screen, okay, good. All right, so I'm not going to touch these routines, so I might as well just push them down. Bye-bye, okay. All right, and I'm not going to touch anything up here. Okay, so it's basically in this main program that I'm going to be working, just this little section in here. Okay, so first of all, I need to add a define statement to define how big I want my array to be. So maybe man 200. Okay, it's a huge number. I don't need it that big, but I want to define a maximum size for an array. Okay? All right, so now I'm going to start to split these things. I want three phases: input, calculation, output. So let's say I'm going to put my, let's say I'll put a little start input. This stuff all down here is basically going to be my next step. I'm going to have calculations. And finally, I'm going to want some output somewhere out here. So I'll have some output down here. Okay. So since I'm going to be, okay, and since I'm splitting things up, my output, this is an output statement. I'm not going to keep it there anymore. It's going to go way down here to the output part. Okay. All right, so he's the output. He's going to go right down to the bottom. I'll be fixing him in a bit. This is another input statement, which I'm not going to use. Remember, my input's all separated, so I'm going to have my calculations in the middle. So I'll just leave the stuff in the calculation stuff in the middle right now. And I got to go up to the input part. Okay. And I'm only going to have one input statement because it's going to be in a loop, right? There's only one read statement. Okay, so I'll get rid of the other one too. So I'm going to have one read statement. All right. So let's start to declare some arrays. What do I need here? I need an integer I or a long I, and I need a H and a T. Okay, two arrays. So long, or maybe I. Okay, and I'm going to want to declare some arrays. Double H brackets M, comma T brackets M brackets semicolon. Okay, now I've got my arrays for holding the height and the time. Okay. Okay, now I need my, now I want to start getting input. Okay. So let's start with I equals 0 is what it says here. I need to initialize I equals 0 first. Okay, I equals 0 is initialized. Okay. Okay. I equals 0 is initialized here, so I'm not initial. Okay, so do. Okay, we're going to put it, maybe I'll do a do while loop. Do, because it says read first. There's no if at the beginning, so it's obviously a do loop. Do. What do I want to do? Get YT. That means I want the address of H0, HI, and the address of TI. Okay, because I equals 0, so it's going to be H0 and T0 I'm going to get first. Okay, once I've got them, I'm going to increment I, right, because I want to get the next one. And now I need my condition to end. While, what was my it says right here, t is greater than or equal to 0. Okay, while t brackets I is greater than or equal to 0. Okay. Forgot that guy. Okay, they're matched. Input is finished. Okay, I've just finished doing this whole input section is now all finished. Okay, I've done the input phase, now it's completely written. Okay, so you can see we've written the input phase. Okay, input phase is finished. Now we start to do the calculus. Next, what do we got here? N data equals I. N data equals I. Okay, and data equals I. Okay, fair enough. Okay, but okay, 0, 1, 2, 3, 4. Okay. Okay, that's this line here. Now I'm getting ready to calculate velocity. So calculate velocity, or v of t. Okay. Okay, at this point, I know how many loops I need. So for I equals 0, I less than n data, I plus plus. Okay, I know I've got, that will give me one loop for each piece of data. And that's these guys coming in. Okay, dy dt is no longer dy dt, it's v of k equals h I plus 1 ti plus 1, and my vt of k, not k, I don't have any k, I only have i's. Okay, sorry, I. Okay, I equals c mean of t I and t I plus 1. Okay, and that's everything that's in this loop. Okay, and oops, I haven't declared any, these guys are not declared yet, so I better do that up here. Double V M and TV M. Okay, so I've now declared these guys and I've calculated velocity. All right, what's my next step to do? My next step, oh, it says it should be n data minus 1. Okay, I'll trust my UML. Okay, I'll put a minus 1 here. Okay, I don't want to do the one, okay. So next I have to, according to my UML, I have to calculate acceleration. So calc A of t. All right, we're calculating A of t. That means I'm going to need to declare something to put these things in. So I'm going to need another double set of doubles. One for the A and one for the t of A. Okay. And I can just copy this, right? Because it's the same calculations here. It's just A instead of V, so I just have to change this. A, V, V, T, V, T, V, T, V, and TV and oops, TA. Okay, all right. So now I've got my calculation for acceleration. Okay. And finally I've got, okay, this is, I don't need this anymore. I now have to output. Output is again another loop. Okay, for I equals 0 less than n data. Oh, this should be n data minus, this is my UML, so this should be minus 2 because we're losing an extra spot. So let's put that to n data. Okay. And I have to print everything. Okay. That can just be one line, %LF, %LF, comma. What have we got here? We've got H brackets, I brackets, T brackets I. Okay, what else do I need to do? I also am going to want to put V brackets, I brackets, TV brackets, I brackets, comma, A brackets, I brackets, comma, AT brackets, I brackets. Okay, so I'm going to have all that. And this guy, no, I need a comma in front of these guys. Let's put a few more of these. If I don't put a comma here, I can extend this way. %LF, comma, %LF, comma, %LF, comma, %LF, slash n. Okay, and I may put a comma. I don't want to. I'll just put it there. Okay. All right. So this is going to give me 1, 2, 3, 4, 5, 6 things. And I have 1, 2, 3, 4, 5, 6. Okay, I think that should complete the code. We've got now that each phase is done. There's the output phase, the input, output, acceleration, everything in the middle. Okay. I would then want to go to try to come. Where's my C program compiler? Let's try to find that. I gotta get this. Okay, so I move him back here. I called it M5 GCC minus C minus wall M5 point C. Whoa, lots of errors. Okay. Conflicting types for T. Oh, I forgot to get rid of this line. Okay, because I now have 2 T's. Okay, not good idea. Okay, delete it. Okay, let's try again. Okay, fewer areas this time. And data is undeclared. Okay, so I need to create a new, I forgot end data. Okay, this one says end data is undeclared. First use in function, so I just create end data here, I declare it. Okay. Next, try again. Okay. C mean defined but not used. Okay, don't worry about that. First of all, check the guy at the very beginning. BT is undeclared. Oh, I called it TV. Oops. All right, get rid of that. Correct that mistake. And then try again. I only correct one mistake at a time. I get another one here, an AT. Oh, it should be TA, okay. Correct it. Okay, 31, the TA part, okay. Try again. Okay. It's missing, okay, I've got these two are together, these two are together, these two are together. Oh, Tameo Pangyo. Okay. So I need to get a Pangyo there for him. Okay, these two now are together, and these two are together. Okay, everybody's together now. Okay, good. Hopefully everything will work this time. Nope. See me, defined but not used. Why? Okay. I got it. What's my first error? Unexpected declaration at end of input. Okay, so we've got some problem with our inputting here. And I will, okay. Do we see our error somewhere? I'll move you, get rid of these empty spaces so I can look more. Okay. Try to figure out where is our error. Somewhere there's an error. Defined but not used. It's not calling this for some reason. Okay. We will have to. Oh, 4:10. Okay, sorry. I gotta give you a 10-minute break. Okay, 10-minute break. You gotta get your 10-minute break. Okay. Okay, we're gonna get started again. Okay. Okay, let's get started. Okay. I think problem for this code is I forgot to save it. Okay, let's save it. Okay. All right, saving. Yeah. C minus O M 5.exe M 5.0, and I'm not using. Am I using anything else? I don't think so. I'm not using. What did it get YDT? Does it call anything? No, it's using fscanf, so I don't need standard input file. Okay. Okay, and remember from before I still have, do I have the directory /w? Yes, I still have mgdt.csv. Remember this file's got type mgdt.csv. It has all the numbers right for the distances. Okay, so I can now try to run my program. M5, I'm going to take as an input mgdt.csv. I'm going to send as an output, let's just call it out.csv. Okay, I'm creating an output file. It ran, and then I just type out.csv, and hopefully it'll open okay. And it's giving a message, how do I want to, okay. All right, and there's basically our output. Okay, this is not, I don't really want these input things here, so let's get rid of this. I'll modify it. I don't need this anymore because I'm using a file. Let's just get rid of that. Okay, and I'll scan that. Okay, let's try again. Okay, I'm going to try to run it again. Recompile it. Okay, this should okay. And then let's try to do out.csv again. And it's going to be, hopefully. Oh, wait, will we update? Okay, type out.csv. Okay, there's the distance, time, acceleration is a function of time. Now my updated program is updating. Great. Finished updating. Please wait while we update. Great. Okay. We take a short break while our program updates. Okay. I wonder if I can do Excel. Excel, out.csv. I don't know if this will work. Might. No. Doesn't like it. Okay. Oh, it's now opening, I think. Hopefully. No. Still updating. Office update up. Please, we're updating. Great, okay. Okay, so there's our spreadsheet. So basically this program has allowed us to do the whole gravity into one spreadsheet, and we have the various values coming down. They don't make that much, okay. That's basically the end of that program. Okay, so let's continue on. According to our thing now, I'm going to now walk through understanding this gravity 1. Hopefully you guys, first of all, I'll give you a few minutes to get your gravity working correctly, and then we'll maybe stamp, and then I'm going to walk through it, and then we'll do milestone. Okay? So TAs will help you make sure there's any problem with your gravity program and help make sure it's running okay. All right?